All right, welcome to class, everybody. Couple quick announcements before we get started on the lesson. So this lesson is the last lesson of Unit 3. So this is the last stuff that will be on your test that's starting tomorrow. So for the test, tomorrow's class will be our test review. So make sure you go through the study guide and see if you have any questions from that before class tomorrow. And then the test will be open Thursday, Friday, and Monday. And Monday is when all of your assignments will close, so you won't be able to use a late pass after Monday. So if you have any late assignments from Unit 3, make sure you finish those up before Monday and come prepared to ask your questions on the study guide in class tomorrow. So our lesson today is about complex numbers. And complex numbers are basically two-dimensional numbers where there's a real part to the number and an imaginary part to the number. So let's first talk about what an imaginary number is. So this is the way that I usually think of imaginary numbers. So like the imaginary number I, you can think of it as being the square root of -1. However, the technical definition is that I squared equals -1. And it seems like it's saying the same thing, but there is a reason why it's important to define it this way. And so basically I is a number that we created so that we could find the square roots of negatives. And I don't know why they decided to call it the imaginary number. I think it's kind of interesting. That's like, oh, we'll just call it imaginary. But that's what they call it. And it turns out that we actually do use imaginary numbers to represent things in the real world quite often. Like, for example, if there's like electromagnetic waves or like things like that that need to be represented two-dimensionally, imaginary numbers are very helpful for doing those types of things. So the reason why imaginary numbers exist is so that we can find the square roots of negatives. Because without imaginary numbers, if we only were working with real numbers, there would be no number that if you square it equals -1, right? Because 1 times 1 is 1, and -1 times -1 is also 1, because a negative times a negative is a positive. So that's the definition of an imaginary number. And it allows us to take the square roots of things like this, because if I find the square root of -4, I can think about it as the square root of -1 times the square root of 4. And so the square root of 4 is 2, and the square root of -1 is the imaginary number I. And so the square root of -4 is the imaginary number 2i. Any questions on that? Okay, and truthfully, I don't really ever write this out. I just think through it. So like I say, what's the square root of 4? It's 2. The square root of a negative is going to give me the imaginary number. So you'll have some problems on your homework like that. And then you'll also have some like this. So 20 is not a perfect square, so you can't find the square root of it, but you can simplify it. How would we simplify the square root of 20? Yep. So if we factor this and we get 4 and 5 and 4 factors into 2 times 2, we could rewrite this as the square root of -1 times 2 times 2 times 5. And the square root of 2 squared equals 2. The square root of a -1 equals I. And the square root of 5 can't be simplified. And so this would be the simplified version of the square root of -20. Any questions on that? So basically, anytime you take the square root of a negative, that equals the imaginary number I. Now, with the imaginary number, we need to look at what happens when we raise it to an exponent, because we're going to be multiplying imaginary numbers, and this will show up. So if you have I to the first power, that just equals I. And so that's pretty self-explanatory. And what was the definition of I squared? So if we go back to this, I squared is defined, like this is how the imaginary number is defined. It's defined to be -1. So if I have I cubed, I can think about this as being I squared times I, because that would be the same thing as multiplying 3 i's. You could multiply 2 of them and then multiply an I. And so that means this is going to equal -1 times I, which is just -I. So I cubed is the same thing as negative I. Does that make sense? Any questions on that? And then if you have I to the fourth, what do you guys think that would be? Yep, it'd be 1 because I to the fourth is I squared times I squared, which is negative 1 times negative 1, which equals positive 1. So the imaginary number I can be simplified pretty often if you're raising it to a power. And this pattern will repeat itself as you continue raising it to other powers. Like if you did I to the fifth, well, this is going to be I squared times I squared times I. Well, since I squared times I squared is negative 1 times negative 1, that makes this a positive 1 times I. And so I to the fifth equals I. And then you could do the same thing, like I to the sixth is going to be I squared times I squared times I squared, which will equal negative 1. Because if you do negative 1 times negative 1 times negative 1, you'll end up with negative 1. And so essentially, any I raised to any power will always be one of these 4 answers. It will either be just I, negative 1, negative I, or 1. And so you might see a problem like this one show up on your homework where you're asked to find I to the 56th power. So essentially what you want to do on this is you want to say, well, how many I squareds do I have? Because I know an I squared equals negative 1. So in this case, how many would we have? 20 what? 28. Okay, perfect. And how'd you figure out that it was 28? Perfect. Yep. So we'll essentially have 28 I squareds. And remember that I squared equals negative 1. And so this is going to equal negative 1 to the 28th power. Well, if you do negative 1 times itself 28 times, what does that equal? 1. And it's going to be a positive 1 because every pair of negative 1s that you multiply will equal positive 1. And so since this is an even number, that means that it will simplify out to be 1. So I to the 56th power ends up equaling 1. But you could also have problems like maybe figuring out what I to the, I don't know, let's do like 47th power would be. And in that case, how many I squareds are there? Yep, so we have 23 I squareds. I'll just draw some dots for that. And then I also have an extra I that is not squared, right? Because I could use 46 of my I squareds to make 23, I could use 46 of my I's to make 23 I squareds. And then I would also have another I. And so then I would say, okay, well, every I squared equals negative 1. So this basically equals negative 1 raised to the 23rd power times I. Well, what's negative 1 to the 23rd power? Yeah, so it will be 1. Is it positive or is it negative? Negative, because if you have an odd number of negatives multiplied together, that will make a negative. So this ends up simplifying to negative I. And so again, regardless of what power you raise I to, you will get one of 4 answers. It will either be 1, negative 1, I, or negative I. All right, let's do a check-in real quick. Scale of 1 to 5. How are you guys feeling about that? Okay, awesome. So now let's talk about complex numbers, because this is where the majority of your homework is based. So a complex number is basically a 2-dimensional number where part of the number is real and part of it's imaginary. So in this one, the 7 is the real part of the number and the 3i is the imaginary part of the number. And in this lesson, we're going to learn how to add, subtract, multiply, and divide complex numbers. So let's start off with adding. So when you're adding complex numbers, you can pretty much just treat the I as if it were a variable. So like you can think about this as if it were polynomials we were adding together, where you had like 4 plus 5x plus 9 plus 3x. And you'd say, well, does this set of parentheses, like, do I need to distribute anything? In this case, I don't because there's nothing out front. So I could just write this as 4 plus 5i. Then for the second set of parentheses, I need to distribute a positive 1, which won't really change anything. So that'll be plus 9 plus 3i. And then you just combine like terms as if it were a polynomial. So I is not a variable because it's a specific number. It's the square root of -1, but you can kind of treat it as if it were a variable. So we'll say 4 plus 9 is 13, and 5i plus 3i is 8i. And so this complex number is the answer to those two complex numbers being added together. Then you do the same thing or the same type of thing for subtracting. So in this case, these parentheses don't really impact anything because there's nothing to distribute. So you do 2 plus 5i. Then the second set of parentheses does matter because you're going to be distributing the negative, and you end up with positive 7 and positive 3i. And then you can combine the like terms because 2 plus 7 is going to equal 9, and 5 i's plus 3 i's is going to equal 8 i's. Yeah.
Why would you get a positive 7?
Oh, you guys are right. Thank you for catching that. Yes. I did that too fast. It should be a -7 because you're distributing a negative to a positive 7. Yep. And so that would change this, and this would be -5 plus 8i. Yep. Okay. Any questions on adding and subtracting? Okay. So on your homework, let me just show you an example of one of the more challenging adding and subtracting ones. So on this one, kind of the structure we have is we have a complex number minus 2 other complex numbers that are subtracted within brackets. So what do you guys think we would simplify first? Yep, we'd want to simplify inside of these brackets. So I'm going to look at these parentheses and see if any of them need to have anything distributed. So this first set of parentheses doesn't have anything. And so I would just write that as 4 plus I. This set of parentheses, though, is being subtracted. So I'm going to distribute that negative, and that gives me -2 plus 3i. All of that stuff is in the brackets, and that's being subtracted from 3 plus 3i. And I can get rid of these parentheses as well because there's nothing that needs to be distributed. Okay, then I'm going to go ahead and simplify this so I don't have to distribute my negative to like a whole bunch of different things. So 4 minus 2 is going to be 2, and I plus 3i is 4i. So this is the stuff in the brackets. And then since I'm subtracting the stuff in the brackets, I need to distribute that negative to both terms in there. So that gives me 3 plus 3i minus 2 minus 4i. And that's going to equal 1 minus I as my answer. So this complex number is the result of taking this complex number, subtracting this one, and then taking that result and subtracting it from this. All right. So we've talked about addition and subtraction. Let's talk about multiplication. So based on the fact that you can basically treat imaginary numbers as if they were variables, what do you guys think the first step would be? Or how do you think we would multiply complex numbers? Yep, we would FOIL, because like if these were X's instead of I's, you would just FOIL them, right? So if we FOIL this out, 3 times 6 is 18. 3 times 8i is 24i. And then -4i times 6 is -24i. And -4i times 8i is -32i squared. Now, this is one thing that is different than polynomials. What does I squared equal? -1. So anytime you see an I squared, you can replace it with a -1. So if this equals -1, -1 times -32 is going to make this entire term +32. Everybody good with that? So that's the only thing that's different about foiling complex numbers versus foiling polynomials. If you had a polynomial and this was an x squared, you couldn't just get rid of the x squared and change the sign. But because it's an imaginary number, you can replace it. So now that I've simplified the I squared, these two i's can't be simplified because they're not I squared. So they still stay there. And so then we just combine like terms. And I say 18 plus 32 is going to give me 50. And then 24i minus 24i will give me 0i, which I could just write my answer as being 50. So in this particular case, they cancel each other out, but that won't always be the case. Sometimes you'll end up with, 7i or something like that. Any questions on multiplying complex numbers? Okay. So on your homework, I'm just going to kind of skim through a couple questions. You'll have some questions like this. This is question 20, where you'll need to multiply two complex numbers together. And then you'll also need to square two complex numbers. So you would want to write this out as 4 plus 3i times 4 plus 3i. And you would FOIL this out and FOIL this out, and then add the results together. Because remember, with order of operations, you always simplify exponents first. So you would square this, and then after you simplify exponents, then you simplify multiplication, and then you can add and subtract and combine like terms. So that's just kind of some guidance on question 20, because there's kind of a lot of parts. Do you guys want me to work through that one, or? Okay, I'm seeing some head shakes, so I'll just go ahead and show you the other one. And if you need help with this, I can help you during homework time. So another one that just kind of to give some context around this is if you're cubing a complex number, basically you're going to need to FOIL twice. So you do 5 minus I times 5 minus I times 5 minus I. And you'd start off by FOILing just two of them, and you'd simplify it all down, and you're going to get some answer. Then you'll take that result and FOIL that with this. So I think we've done some polynomials like that, but not a ton. So I just wanted to make sure you guys know how to cube that. Any questions on any of the multiplying? Yeah.
I think you multiply 0 with
You can. It just equals 0. So here, if you do 0 times any number, you get 0, and 50 plus 0 is 50. Yeah. So you could this is still correct. It's just this is more simplified. Yeah, good question. Any other questions? So the last thing we need to talk about is dividing complex numbers. So we've learned how to add them, multiply, and subtract. And if we have a complex number divided by another complex number, the way that you simplify it is not really by thinking about it as division. Instead, we're going to kind of think about it as if we were rationalizing the denominator. Because remember, I is the square root of -1. So this expression is equivalent to 2 minus the square root of -1. And we talked about when we were working with rationalizing denominators, how if you took the conjugate of this and multiplied by it, how it would cancel out the square root. And so essentially that's what we're going to do here. And we're going to make it so the bottom of the fraction doesn't have an I in it anymore. So basically what that looks like is we say, okay, well, what's the conjugate of 2 minus I? And it's technically called the complex conjugate because you're working with complex numbers. But we take, oh, go ahead, what is it? Perfect. Yep, so we have 2 plus I is the conjugate, so I'll multiply the top and the bottom by it. And when I multiply the top of my fraction by this, I end up with 10 plus 5I plus 6I plus 3I squared. Then on the bottom of my fraction, I'm going to get 4 plus 2I minus 2I minus I squared. And again, the whole conjugate thing is to make it so that these two terms cancel each other out. And so when I simplify this, I know that I squared equals -1. So this term is going to equal -3 because I'll have -1 times +3. That gives me -3. And then what is this term going to be? Say it a little bit louder. Yep, positive 1, because this part is -1, but -1 is +1. So we'll get a +1 there. So now I can combine all my like terms. So on the top, 10 minus 3 is 7. 5 i's plus 6 i's gives me 11 i's. And then on the bottom, I have 4 plus 1, which is 5. And then 2 i's minus 2 i's cancels out. And that's the whole point of multiplying by the conjugate, is so that this happens, because now this is a single complex number. We started with 2 complex numbers that were being divided, and now we just have 1 complex number. And you could write it like this, or you could also write it as 7/5 plus 11/5 I. Because remember, a complex number has a real part and an imaginary part. So this is basically the real number part, and this is the imaginary number part. So on your homework, they have some where like they kind of build this structure for you, and then you fill in the blanks of like what these numbers should be. They also have some where you have to type them in. If you have to type them in, make sure you type it in like this, because there's a couple people in my last class where they were like typing in the correct answer, but they typed it in like this. And for whatever reason, the homework system wouldn't accept it. I don't know why, but because this should be right. But if you're having issues with it accepting the answer and you're like, I'm pretty sure this is right, just separate it out into a real part and an imaginary part, and that should fix it. So that's how you divide complex numbers. Do you guys have any questions on that? Okay, cool. So dividing complex numbers, like it's not even really like doing division. It's more like using the conjugate to get rid of the imaginary stuff in the denominator. So it's more similar to rationalizing the denominator than actual division. So that's how you do those. If you have any questions, let me know and you guys can get started on your homework.